the Euler much better result as compared to the simple Euler method, modified Euler's result. In modified Eulers, I have to perform more calculation in each step. So this is how we enhance the accuracy. We have to perform more calculations in each step rather than moving ahead. Euler's method, modified Euler's method. Sorry, I'm not writing again. The problem is same. There is a rod, time t0, temperature 20. Then we need a temperature at 10 seconds. Let's have two intervals. So h is 5. Rest of the problem is same. We just need to define one time. Do not, if you are solving a same problem with different methods, just for comparison. So h equal to 5 in this case, and we have given that t naught is 0. Also it is given that u naught is 20 degrees centigrade. Okay, so this is all given to you. So let's start the modified Euler's method. You should remember the general scheme which I drive in a later stage. This is the general scheme of the Euler's method. If you remember, we just apply a Euler's scheme first, so we will get some predicted or a trial solution, and then based on that solution we will predict our solution at new time step. Okay, so by averaging this quantity. So there are, to move from one stage to the other stage, I need to perform two calculations in every step. So the calculation will increase in modified hours. So let's do the calculation here. So the formula in terms of u and t, that's the important point, would be y steric, no y, sorry, this is a mistake. U steric is equal to, just like a normal Euler scheme, ui plus h times f of ti ui. F for ti ui is same as the previous one, q times of t. It changes in problem wise. Whatever the problem given to you, you have to select accordingly. And we all know that I in this case still runs from 0 to 1. But this is not the exact answer. It is not ui plus 1. It is just some prediction. What we have to do to obtain the solution at new time, but this solution belongs to u static, belongs to at ti plus 1. That is the ti plus 1. Now ui is equal to ui plus h f of ti ui, not plus, comma. Write down properly, maybe it causes confusion to the student. So this quantity plus, I told you, if you remember in the last lecture, this is the average value, ti plus 1 comma u static, that is a y static, but here is the u static, divided by 2. This is the average of the two slopes, and whatever be the solution you get is ui plus 1. So this is at what time? It is ti plus 1. This is the final time that you want to work. So for each step, that is still the geometry is same. You will have t naught. You are using two intervals, so there is a t1 and the ending time is t2, which is 10 seconds, 5 seconds, and 0 seconds. Okay, u naught, u1, u2. u naught is given to you 20. Using this, you have to find u1. Once you know the u1, you have to use t1 and u1 to find u2 at t2. This is how the scheme will work. But for moving from there to there, in Eulers you need to perform only one calculation. But here you have to perform two calculations each step. First you have to find u star, and then using u star, you and this solution you will predict the solution on the next time slowly. Okay, so that's the main difference. In modified, you have to perform two calculations in each step, from there to there, from there to there, based on the previous data. That's the main point. Okay, so I'm going little fast, little bit, because it's just a simple calculation process which you can easily go through in number of books and references you can find as well. But the main point or good point was that if you want to do it, use computers. Okay, that is a Excel. You can use simple Excel as well. Just put the cells inside the cells so you can get the values easily. or maybe a computer program can help you as well. So it is labor intensive work, like it is not technical calculation, it is the same thing, that just you have to put the data accordingly, but it is just a one by one step. But for the sake of the completeness of this topic, I have to solve one example so that you all know which variable are coming from which variable. But keep in mind the theme is you have to use previous state data to find the solution at new time, new state, and then using that state you can find the solution at further new state, and then using this you can find the solution at further state. Cannot go in a one step from there, although you can go there, but it will not give you the accurate solution, it is compromise solution. Okay, so this is the scheme and I have to run that scheme. Whenever you have to run the scheme, you have to write it down. For I equal to 0, for I equal to 0, this is the index, but what does the index represent? Is represent you want to use the solution t naught, which is 0, and t u naught, which is 20 degrees centigrade. So you are, when you say I0, you want to use this data to find the solution at ahead. So use steric does not have any index is equal to u naught. I am putting that indexes on this formula. Okay, and then in this formula. So u naught plus h times of f of t naught u naught. There is no need to show so much calculations. You can put directly data as well. So u naught is 20 degree centigrade, h is 5, and we know that f is a ut function, u times of, in this problem it is u times of t. Still, those who do not remember from where f comes, so whenever you have any differential equation given, check that is there anything left in the du or t part. If nothing, then whatever be on the right hand side is your f of ut, f of xy, whatever be the variables involved in the differential equation. So this is u not t not or u not t naught, whichever be the signal. So you just need to replace the values. So when we replace it, you will get 20 degree plus 5, t naught is 0, and it's 5 again. So obviously you will get, because just like Euler's method first step, so you will get the 20 degree. So use star. Okay, now use star is there, but this is not the final solution. Although that solution, which is a predicted solution we called in our derivation, that solution is belongs to, we started from t naught, so that solution also belongs to at t equal to t1, which is in this case is 5 seconds. So this solution also belongs to 5 seconds, t1 equal to 5 seconds, but this is the predict solution. Okay, we have not find the solution at 5 seconds, it is just a prediction. So in modified, you have to modify your solution by the following way. So I'm applying now this step in a same, I am still using this data, but I am applying this step. Okay, second step. That's why modified alert also called RK method or stage 2. For in each step you have to perform two calculations. So now the second step, I'm still on I is equal to 0, but I have to perform two calculations. So now this is equal to u1. So how it is u1, you can see here, if I put 0 there, so that will be u1. u1 equal to u naught plus h f of t naught u naught plus f of t1. So note down this t naught, it is t1. Okay, comma u star or y star, whatever be the variable, and this whole term will be going to divide by 2. Okay, so this is the idea. So let's do it like that. u1 equal to u naught. U naught is 20, h is 5, f t naught, which means u naught t naught, or a t naught u naught, whichever be the function, plus this thing is equal to, in place of t you have to put t1, and in place of u you have to put u star, which is computed earlier. They are 20 degrees, and whatever be the answer, it depends. But this is the only part is difficult, because for problem, every problem has its own right hand side, so right hand side changes accordingly. So the final answer is 20 plus 5, maybe I can put 2 here. So whatever left is u naught is 20, t naught is 0, plus t1 is 5, and u steric is 20. Now you just need to evaluate the solution. So this part goes to 0. This will be 2, 10, 10 into 550, 52, 50, something like that. Okay, so the calculation would be like this. 250 plus 20. Okay, now student, the predicted value is different now. It's 270 degree centigrade. Okay, this is not the final solution. Obviously, it is at. Okay, this is not the final solution. Obviously, it is at t1 equal to 5 seconds. But so I have found the solution here u1. But to move from in modified alarm to move from this state to this state, I need to perform two calculations. First, I need to find u star, and then I have to find u1 based on this. But now I will use index 1, so I will use only this data to move from there to there. But same thing, due to the modified order, I have to perform two calculations. Okay, so this is how the process works. So in modified, but keep in mind you can compare it. So in Eulers you will have, so note down this, using Eulers your answer is 20 degrees centigrade at t1 equal to 5 seconds. But using modified Euler, based on the differential equation, your answer is still at 5 seconds, but it's 270. There's a huge difference between these quantities because the random problem. But point is that it is just like that. It is a smooth represent the solution like this. But similarly, it is not the end because we need a solution at 10 seconds. We have just computed the solution at 5 seconds because we are using two intervals. So we need to move one more step ahead. But for each step, I have to perform two calculations because of the modified Euler's scheme. So if you understand that part, you can also understand that the third method that we have discussed is RK method of four stage. What will happen in four stage? We have to perform four calculations while moving from one step to another. So work will increase, but that increase at the cost of making your method much more accurate. So this is a good thing. We do not need to solve manually. Usually we do computer program with it. We define a starting value, we define ending value, we define our right hand function, and we just need to provide the data inside. So that's in that case it is very useful for us. But here we are doing something different. So let's complete this problem. I equal to 1. For I equal to 1, first I have to, what does this mean? I equal to 1, you are at a stage where t1 is 5 seconds and u1 which you just found in the last step is 270. So this is also the point that you cannot find the solution at t10 because you have to first find the solution at 5 seconds and then you have to find the solution at 10 seconds because you are using two. You have to go step by step because this is going to be used in the other calculation. So again, you are at I equal to 1, you have to first find the predicted solution. So you use the same symbol, use direct. But keep in mind, use direct only holds for this calculation. So this is equal to u1 because I is 1 plus h f at t1 comma u1. In previous it was t0 and u0. So what should we do in this case? So we have to replace it. u1 is 270 plus h is 5. I hope that I have mentioned many times what is f, so I'm doing directly. It is t1 times u1. So t1 is 5 and u1 is 270 still. So you have to compute this predicted value, and that predicted value belongs to t2 equal to 10 seconds. It is not the final answer, it is just a prediction. That's why it is u star. So let me compute this quantity for you. So that is equal to 5 into 5 into 270. Simple calculator, although that is not showing any realistic results, but plus 270. So reading that I am getting here is 7020. Also because it's a dummy problem, so it shows that the temperature predicted value saying it will be going somewhere 7020. Okay, we said okay because the dummy data, but we want to understand the process of computing. Okay, so then this one is U static. So U2 will be equal to U1 plus H f of T1 U1 plus f of T2 U1 U static, sorry, not U1, divided by average of these two slopes. The slopes, these are the slopes, and we have to find the average of these two quantities. And that belongs to the exact time at t 10 seconds as well. But this would be the final answer. So let's perform this calculation. U1 is 270 plus H is 5. We know that this is U into T, so it's a T1 times U1. T1 is 5. T1 is 5. U1 is 270 again plus T2. T2 is 10 seconds and U2 star. We have just computed U2 star. It's very huge reading, but we are not interested in exactness of the solution. We are interested in the process of computation. So this and divided by 2. So this is equal to 270. Let me write down the final answer directly, but you understand we just need a calculator to compute these quantities. So let me compute for you. This will be 10 into 7020 plus 5 into 270. That's a very huge number. Divide by 2. Okay. Multiply by 5 plus 270. So this is the predicted temperature. Okay. Although it's a dummy example, but let's say this is the predicted temperature we are having at T2 equal to 10 seconds. So the experiment says this will be going like this. Then just to give you some understanding that obviously there exists some phenomena in which you will have this type of drastic increase, but this is just because we have selected a dummy problem. Like this one is just a dummy, it's not necessary. So based on that, the prediction is like this. Temperature is increasing very fast. In this case, we can clearly see. But sometimes these type of problems are stiff problems in which says that slight change in any value in t, you will get the faster change in the dependent variable. So but that's the one remark. So point is at the moment is important is you have used Euler's, you have used modified to predict the solution. Okay, this is how you predict the solution. Okay, so keep in mind this is strategy of working. So for each step in modified Euler, moving from one step to the next step, you have to go by certain steps. Okay, you cannot go directly to the next step, you have to go step by step. So this is how the process works. Okay, so this is how the process we have defined. Ignore the reading. This is how the process works for the Euler's method. And similarly